next speaker will be Eduard Loscos with his title New Advances in Smart Textiles. He's from Cetemmsa, so we will now hear the home talk.
Thank you, Stefan. Good morning, everybody. I'm Eduard Loscos from Cetemmsa. Stefan introduced myself. I wanted to make a small picture of what is going on in smart textiles nowadays. But my idea was at least try to get some samples from what is done nowadays, and I think that the European projects that is running nowadays could be a good example of what is moving on. Actually, there are not many projects, so but it's true that using textiles as a substrate is very tough. You don't even need a microscope to know why. Okay? Try to printing or to do things in textiles is very difficult. But however, we could see that there is a lot of project that has been that is finishing in the short term, and new project that is starting this year. First of all, I want to stress safe at sea. This project aims to get monitoring the sailors. The idea is to use a state-of-the-art textiles and getting all them together and using an ergonomic design, but also to put in electronics inside, so ICT systems could be implemented. Afterwards, we've got Pasta. Pasta is a really good name for a European project, I don't know. Actually, Pasta comes from the Stella project, which used to be an FP6 project around stretchable electronics. And as you will see, stretchable is the key point to put things on textiles. With Pasta, the idea is to be able to put very tiny things, because microelectronics is becoming more and more smaller. So the idea is putting these microprocessors in yarns, so and interconnected them with printed electronics, for example. So you could get the stretchability with printed, and you could get the good performance of silicon electronics. And obviously the applications is in outdoor sports, luminous textiles, and motion systems. Moreover, other approach, this is different approach for putting things on textiles, and it's called ITEX. Later on, we've got the place it. Well, the idea is you already taught it, is put into textile electronics, silicon electronics with a stretchability again. They are looking for a stretchability of even 50%, with a bending radius down to 0.5 millimeters. So the integration of chips, they are planning to do also with coaching. Correct me if I'm wrong, but they told about this idea, and I think it's a really good approach to that, and focusing for healthcare, for skin diseases, and monitoring and consumer products. Because when we think of textiles, I have to be honest, first time when I came to Cetemmsa, I thought, okay, textiles, you know, it's a kind of old-fashioned thing, so who cares? You can make socks, okay, and maybe suits, but it's true that we are completely surrounded by textiles. For example, in construction, in aeronautics, in industrial processes. So, moreover, we are here focused on garments and footwear, but to be able to put electronics on textiles means a lot more than just clothing and monitoring. And there it is, one project. Cetemmsa is here. The idea of this project, I think it's brilliant. it's not meant to put something on textiles, but that make the textile by their own to have properties. So they are building, the idea is building the yarns as a DSS cell, so a dye-sensitive cell, and the other fibers should be batteries. So you could get the, the stretchability is not an issue here because you've got the fibers. The problem here is the interconnection between the battery and but I don't know, we are on it, and if we could achieve good results, I think it's a really good approach, because if you are working, take in mind, at the end, textiles is pure mathematics. Okay, you are making knots, and with more knots, and you are building 3D structures at the end. So if you could work with yarns, it's very interesting because you could do a lot of things in this interconnection. Again, there is a CSA approach, and it's called SustaSmart. And the idea of this project is supporting standardization. This project is coordinated by Cetemmsa, and the idea of this project is put printed electronics into an insole, so you could get not just to know if the people has fault, that you could, okay, it's something that there are many projects inside the AL, for example, focusing on that, but the idea is try to prevent them. A project that we already finished in 2011 was called the Photex, and the idea was printing solar cells on textiles. I think it was the first time we really discovered that printing on textile is tough. It's really tough. But at least we get some functional samples, and I suppose yesterday some of you could see it on Cetemmsa. This was the project I already mentioned before about these copolymers, piezoelectric, and you could get some very interesting sensors for elongation, and with a really good elasticity, and is a very linear sensor, so you could put on textiles easily and work very well. There is a really big project a Spanish project called Infinitex. The idea is, when I mentioned that textiles are everywhere, this project is focused on that, of working in multi-sectoral areas and bring these smart textiles to all these areas. And there is a project that we are starting just now. It's a regional project and is meant to print again on textiles. You know, in Mataró we are a stubborn people, so we are still trying to print over textiles, and actually we are doing it. And what we want now is to doing in a roll-to-roll process, and that's what is focusing this project. So as a summary, today's picture is that we need hybrid devices also here in textile products if we need a good performance devices. And lab demos and prototypes, we have seen sensoring, mostly photovoltaic actuators. That's something that is seen a lot, and to getting these textiles with buttons, and light emitting on textiles to fashion. So current work is to get these hybrid circuits and storage hybrid textile for protective clothing. That's an issue, and that's something for security very interesting. To get vital sign sensoring. This printed strain and pressure sensor for movement monitoring for sports and leisure mostly, and for rehabilitation. Roll-to-roll production of large area for indoor and outdoor lighting, and energy harvesting and storage on textile. And more or less, this is going to be put on the OEA roadmap, so you could see it more closely. And thank you for your time, and if you've got any questions.